Hello, in this lecture we find out the value of x. In the drawing we have a quarter circle, AEF is a quarter circle. Inside this quarter circle we have square ABCD. This is square ABCD. In addition, we know that this is line segment DE is equals to 12 units in its length. This is angle GDC that is equals to theta. This is angle EDC that is also equals to theta. And our mission is to find out the length of this line segment GD that is equal to x, according to what is given as the question. So first of all, we know that ABCD is a square, and you know that all the angles inside a square are right angles, so this angle is a right angle, this angle is also a right angle, this angle equals to 90 degrees in its side. And finally, this angle is also a right angle. In addition, we know that in any square, the opposite sides of any square are parallel to each other. So in square ABCD, side DC is parallel to the opposite side AB. Again, side DC is parallel to the opposite side AB. So I write it down. DC is parallel to AB in square ABCD. But side AB is part of the straight line AE. Again, side AB is part of the straight line AE. And if a part of a straight line is parallel to another straight line, it means that the straight line AE itself must be also parallel to DC. And therefore, the straight line AE itself must be also parallel to DC. So here we can implement rule 15, this drawing. We can take quickly on rule 15. So need to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have line A that is parallel to line B, and we also have those two angles alpha and beta. They are defined as alternating angles, and they are located between the parallel lines A and B, and therefore they are equal to each other. That is to say, angle alpha equals to angle beta. So we can implement rule 15 in our drawing. In our drawing, we have those two angles. They are defined as alternating angles, and they are located between the parallel lines DC and AB, and therefore they are equal to each other. So those two angles are equal to each other according to rule 15. This is angle CDE, and this is equals to this angle. This is actually angle AED. Angle AED, and they are equal to each other according to rule 15. Okay, again, those two angles are defined as alternating angles, and they are located between the parallel lines DC and AE, and therefore they are equal to each other. So those two angles are equal to each other according to rule 15. But this is angle theta according to what is given as the question. So can I say that angle CDE equals to theta? Here angle CDE equals to theta. And from this equation, theta equals to angle CD equals to angle AED, we will derive that angle AED is also equals to theta. Angle AED equals to theta. So actually, this is angle AED that is equal to theta. Okay. In the next step, we'll do a construction, that is to say from point G, we'll do perpendicular on AB. Again, from point G, we'll do perpendicular on AB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point of the perpendicular GN with side DC as M. By doing this construction, we created quadrilateral DM and A. This is quadrilateral DM and A. Inside this quadrilateral DM and A, we have 1, 2, 3 right angles. This angle is a right angle. So inside quadrilateral DM and A, we have 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle in total must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. So this missing angle must be equal to 90 degrees in its size. So inside this quadrilateral DMAN, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral DMAN that has 4 right angles as a rectangle. So I write it down. This quadrilateral DMAN is a rectangle because it has 4 right angles. GN is perpendicular on AB. Again, GN is perpendicular on AB. So GN is a perpendicular, it is absolutely a straight line. GN is a perpendicular, it is absolutely a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, triangle DGM is a right triangle. So I copy this right triangle GDM in a new page and we will analyze this right triangle, triangle GDM. So actually, this is the right triangle GDM that I copied from the original drawing. In this right triangle GDM, it is very easy to see that cosine theta equals to dm over dg. So cosine theta equals to dm is the missing side, so we leave this it is, over dg. dg equals to x, so we solve dg by x. So if we're going to finish according to equation 1, we actually found out that cosine theta equals to dm over x. So here we multiply this equation 1 by x. And finally we found out that according to equation 1, according to this equation 1, dm equals to x times cosine theta. We will define one side of this square ABCD as y, therefore AD equals to y. Side AB of square ABCD equals to y because of the fact that all the sides of any square are equal to each other. Side CB also equals to y. And finally side DC equals to y in square ABCD. What is the definition of line segment AE? Line segment AE starts from point A, that is the center of the quarter circle, and ends at point E, that is the point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is actually the radius of this quarter circle. We define the radius of this quarter circle as R, therefore AE equals to R. So in the next step, I'll copy this right triangle ADE in a new page, and we will analyze this right triangle ADE. The hypotenuse DE of the right triangle AD equals to 12 units in its length, according to what is given as the question. So actually, this is the right triangle ADE. This is a copy from the original drawing. In this right triangle ADE, cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. So in total, actually found out that according to equation 2, cosine theta equals to R over 12. This is according to equation 2. Well, according to this equation 1, we have already found out that dm equals to x times cosine theta. So we have here two equations. Now we can substitute cosine theta in this equation 1, by r over 12 from this equation 2. We'll do it now. We will get that according to equation 1, dm equals to x times cosine theta. And cosine theta is r over 12 according to equation 2. So in total, we actually found out that dm equals to xr over 12. dm equals to xr over 12. This is side dm, that's equals to xr over 12. dm equals to xr over 12. We have already found out that quadrilateral DMAN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMAN, side DM must be equal to the opposite side AN. But DM equals to XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule, in the same rectangle DMAN, side DA must be equal to the opposite side MN. But DA equals to Y, therefore MN must be also equal to Y. In the next step, I'll copy again the right triangle DGM in the new page and we'll continue to analyze this right triangle DGM. So actually, this is the right triangle DGM that I copied from the original drawing. In this right triangle DGM, sinus theta equals to GM over GD. So sinus theta equals to GM, so GM is the missing side, so we leave it as it is, over GD. GD equals to X, so we substitute GD by X. So we found out that according to equation 1, sinus theta equals to GM over X. So here we multiply this equation 1 by X, and we get that according to this equation 1, GM equals to X times sinus theta. If it again according to equation 1, we actually found out that GM equals to X times sinus theta. So in the next step, I will copy again this right triangle ADE in this new page, and we will continue to analyze this right triangle ADE. Actually, this is the right triangle ADE that I got from the original drawing. It is very easy to see from the drawing that here sinus theta in this right triangle ADE equals to dA over dE. So sinus theta equals to dA. dA is R over dE. dE is 12. So in total I actually found out that according to equation 2, sinus theta equals to R over 12. This is according to equation 2. While according to equation 1, this is equation 1, we have already found out that Gm equals to x times sinus theta. Okay, this is according to equation 1. Actually here, in this equation 1, in this drawing, sinus theta equals to dA over dE. Again, sinus theta equals to dA over dE. dA is y and dE is 12. So in total, in this triangle ADE, sinus theta equals to y over 12. Sinus theta equals to y over 12. This is according to equation 2, while according to equation 1, we have already found out that Gm equals to x times sinus theta. So now we will substitute sinus theta in this equation 1, by y over 12 for equation 2. We'll do it now, and we get that according to equation 1, Gm equals to x times sinus theta. And sinus theta, according to equation 2, is y over 12. So in total, we actually found out that the Gm equals to xy over 12. Sinus theta equals to Gm equals to xy over 12. This is side Gm, and it is equals to xy over 12. In the next step, we will join points A and G together by straight line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and then set point G, that is point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, GA is the radius of this quarter circle, that is equals to 1 according to our definition. By joining points G and T together by straight line, we created the right triangle AGN. So I'll copy this right triangle AGN in a new page, and we will implement on this right triangle AGN the Pythagoras theorem. Here, by PT is the abbreviation for Pythagoras theorem. The hypotenuse AG equals to R. We have already found out that side AN equals to XR over 12. So what is the length of side GN of the right triangle AGN? What is the length of side GN? From the domain, it is very easy to see that the GN in total equals to GM plus MN. And again, GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. So actually, this is the right triangle times AGN, that the covers from the original domain. This right triangle AGN, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle AGN, the hypotenuse is AG, therefore the square of the hypotenuse is AG square, and it is equals to AN square plus GN square. AG, the hypotenuse AG equals to R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square. XR over 12 square equals to X square times R square over 12 square, that is 144. So in total, XR over 12 square equals to X square times R square over 144 plus GN square. GN equals to xy over 12 plus y, therefore GN square equals to xy over 12 plus y squared. So I write it down. So according to equation 1, we should have found out that R square equals to x squared times R square over 144 plus, here we have this expression, so we take y as a common factor from this expression, and we get here, so y was taken down to a second factor. So what is left from xy over 12 after we took from it y as a common factor? What is left is actually x over 12 plus what is left from y after we took from it y as a common factor? What is left is actually 1 all squared. So according to equation 1, we found out that R square equals to x squared times R square over 144 plus, we have here this expression. Actually, we have here the algebraic identity that says that a times b to the power of m equals to a to the power of m times b to the power of m. So according to this algebraic identity, we will get that y times x over 12 plus 1 square equals to y square times x over 12 plus 1 square. Okay, so actually, according to equation 1, we found out that R square equals to x squared times R squared over 144, and here we have y squared times x over 12 plus 1 square. So it is plus y squared, and here we have x over 12 plus 1 square. So here we multiply 1 by 12 and then we divide it by 12 in order to overcome factor with x over 12. So 1 times 12 is 12. So in total, the numerator of this expression, we will have x plus 12 divided by 12 all squared. Okay, repeat again according to equation 1, we actually found out that r squared equals to x squared times r squared over 144 plus y squared times x plus 12 over 12 squared. So actually, according to equation 1, we found out that r squared equals to x squared times r squared over 144 plus y squared, and here we have x plus 12 over 12 squared. Here we use the following algebraic identity that states that a over b to the power of m equals to a to the power of m over b to the power of m. And according to this algebraic identity, we get that x plus 12 over 12 squared will be equal to x plus 12 squared over 12 squared. And 12 squared is 144. So in total we shall find out that x plus 12 over 12 squared, according to this algebraic identity, equals to x plus 12 squared over 144. Okay, so this is equation 1. In the next step, we will join points A and C together by straight line. Again, we join points A and C together by straight line. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and then at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle that equals to R according to our definition. Actually, by joining points A and C, we created the right triangle, triangle ABC. So I'll copy this right triangle, triangle ABC in the new page, and we will implement on this right triangle, triangle ABC, the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. We just right now found out that the length of the hypotenuse AC is R, equals to the radius of the quarter circle, that is R. AB equals to Y, and BC also equals to Y. They are both the sides of the square, and all the sides of any square are equal to each other. So actually, this is the right triangle, triangle ABC, that is according to the original drawing. In this right triangle, triangle ABC, according to the Pythagoras theorem, AC squared, this will be equation 2, AC squared equals to AB square plus BC square. So AC is y, AC is r, therefore AC square is r square, and it is equals to AB square. AB is y, therefore AB square is y square, plus BC square. BC is also y, therefore BC square is y square. So in conclusion, according to equation 2, we found out that r square equals to y square plus y square is 2y square. So r square equals to 2y square according to equation 2. Repeat again. According to equation 2, we actually found out that r square equals to 2y square. This is according to equation 2. While according to equation 1, we've already found out that r square equals to r square times x square over 144 plus y square times x plus 12 square over 144. So we have on both those two equations r square, and therefore we can substitute r square in this equation 1 by 2y square for this equation 2. We'll do it now, and we'll get that according to equation 1, r square is 2y square, and it is equals to r square, and r square is 2y square times x square over 144 plus y square times x plus 12 square over 144. So here we divide this equation 1 by y square, and we get that according to this equation 1, 2y square over y square is 2, and it is equals to, here y square will get cancelled, and we have to leave with 2x square over 144 plus, here y square also will get cancelled, and we have to leave with x plus 12 square over 144. So here we multiply this equation 1 by 144, and we get according to this equation 1, two times 144 is 288. Here 144 will get cancelled, and we have to leave with 2x squared plus, here 144 will also get cancelled, and we have to leave with x plus 12 squared. In the next step, we'll open the brackets of this expression, and we get that according to this equation 1, $288 equals to 2x squared plus x plus 12 squared. x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12 is 24x. So we found out that according to this equation 1, 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we subtract 288 from this equation 1. We found out that according to this equation 1, here 288 minus 288 is 0. This is equals to, so 0 equals to 3x squared plus 24x, and we have 144 plus 288 is minus 144. So here we divide this quadratic equation by 3, and we get that according to this equation 1, 0 over 3 is 0, and it's equals to 3x squared over 3 is x squared, plus 24x over 3 is 8x, and minus 144 over 3 is minus 48. So actually we found out that x squared plus 8x minus 48 equals to 0. So I copy it here. X squared plus 8x minus 48 equals to 0. So actually this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, here the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we put the values of a, b, and c that we found for our specific quadratic equation in this general formula for x in order to find out the value for the values of x for our specific quadratic equation. And so we'll do it now, and we get that x equals to minus b. B is 8, therefore minus b is minus 8, plus minus square root of b squared. B is 8, therefore b squared is 8 squared, that is 64, minus 4 times a times c. So it is minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 48, therefore minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 divided by 2a. A is 1, so a is 2 times 1, that is 2. So actually found out that x equals to minus 8 plus minus and inside the root we have 64 plus 192. 64 plus 192 is 256 divided by 2. So we found out that x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x equals to minus 12. Okay, x equals to minus 12. But actually x can never be equal to minus 12. Why? Because of the fact that x is the length of this line segment GD, and x as a length must be a positive number. So the negative solution for x is irrelevant, incorrect, so we'll cancel this solution and we'll take into account only the positive solution for x. And the positive solution for x is that x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So we found out that the length of line segment GD is equal to x according to what's given as the question is equal to 4 units. And that is the answer to the question. I repeat again. The length of this line segment GD is equal to x is equal to 4 units. X equals to 4 units in its length. In the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment GD. This equals to x according to what is given as the question. We found out the value of x. So in the drawing, we have a quarter circle. AFE is a quarter circle. Inside this quarter circle, we have square ABCD. This is square ABCD. In addition, you know that this is line segment DE. That is equal to 12 units in its length. This is again GDC, that is equal to theta. This is again EDC, it is also equal to theta. Again, our mission is to find out the length of this line segment GD, that is equal to x. So, first of all, we know that ABCD is a square, and know that all the angles inside any square are right angles. So those 4 angles are all right angles. And in addition, we know that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to the opposite side AB. DC is parallel to the opposite side AB in square ABCD. But AB is part of the straight line AE. Again, AB is part of the straight line AE, and AB is parallel to DC. And if part of a straight line is parallel to another straight line, then the straight line itself, the straight line AE itself, must be also parallel to DC. So AE, the straight line AE itself, must be also parallel to DC. Here we can implement rule 15 in this drawing. According to rule 15, alternating angles between parallel lines are equal to each other. So you have here line A that is parallel to line B. In addition, we have here those two angles alpha and beta. They are defined as alternating angles and they are located between the parallel lines A and B. A is parallel to B. And therefore, they are equal to each other. That is to say, alpha equals to beta. You can actually implement rule 15 in our drawing. Why? Because in our drawing, we have those two alternating angles. Those two alternating angles, they are located between the parallel lines DC and AE, and therefore they must be equal to each other. So this is angle EDC or CDE, and it must be equal to this angle. This is actually angle AED. So angle CDE equals to angle AED according to rule 15. But angle EDC, this is angle EDC, is equal to theta according to what is given as the equation. So we can write here that angle EDC equals to theta. And from this equation, theta equals to angle EDC equals to angle AED. We've derived that angle AED must be also equal to theta. So this is angle AED that is also must be equal to theta. So in the next step, we did a construction. That is to say, from point G, we draw perpendicular on AB. Again, from point G, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Okay, so actually here, by doing and we also defined the intersection point of the perpendicular GN with side DC as M. So by doing this construction, we created quadrangle DM and A. This is quadrangle DM and A. So inside this quadrangle DM and A, we have 1, 2, 3 right angles. The sum of three right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees. According to the rule, that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Okay, so inside quadrangle DMAN we have 4 right angles, and any quadrangle that has 4 right angles must be a rectangle if not a square. So we will write to this quadrangle DMAN as a rectangle. Okay, and then we have GN is perpendicular on AB. The GN is perpendicular, must be a straight line. So GN is a straight line. So if you focus on this side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at this side of the left side of the straight line GN at point M? We have this angle that is a right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, triangle GMD is a right angle. So I copy this right angle GMD in a new page and we analyze this right angle triangle GMD. This is right angle GMD or GDM that are coming from the original drawing. In this right angle GDM or GMD, cosine theta equals to DM over DG. Again, cosine theta equals to DM over DG. DM is the missing side, so we leave it as it is, over DG. DG is x, so substitute DG by x. So in total, we should find out that according to equation 1, cosine theta equals to DM over x. Here we multiply this equation 1 by x, and finally found out that DM equals to x times cosine theta. This is according to equation 1. In the next step, we defined 1 side of this square ABCD is y, and therefore all the four sides of this square ABCD must be equal to y, and especially side DA. What is the definition of line segment AE? Line segment AE or side AE starts from point A, that is the center of the quarter circle, and then at point E, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We define the radius of this quarter circle as R, therefore AE equals to R. And the hypotenuse D equals to 12 units in its length, according to what is given as the question. So this is right triangle ADE that I got from the original domain. In this right triangle ADE, it is very easy to see that cosine theta equals to AE over DE. Again, cosine theta equals to AE over DE. AE is R, DE is 12, so in total cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1 by R over 12 from this equation 2. We did it and we found out actually that dm equals to x times cosine theta. And cosine theta is R over 12, so in total dm equals to xr over 12. So here, this is side dm, that equals to xr over 12. So we have already found out that quadrilateral DMNA is a rectangle, and we all know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side DM must be equal to the opposite side AN. But DM is XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule, in the same rectangle DMNA, side DA must be equal to the opposite side MN. But DA is y, therefore MN must be also equal to y. Okay? In the next step, I copied again the right triangle DGM in a new page, and we continue to analyze this right small triangle DGM. So actually, this is the right triangle DGM that I copied from the original domain. This right triangle DGM, it is very easy to see that sinus theta equals to GM over DE. Again, sinus theta equals to GM over GD. So sinus theta equals to GM. GM is the missing side, so we leave it as it is, over GD. GD is X, so we substitute GD by X. So in total, we actually found out that sinus theta according to equation 1 equals to GM over X. This is according to equation 1. We multiplied this equation 1 by X, and finally found out that GM equals to X times sinus theta. Again, GM equals to X times sinus theta. This is according to equation 1. In the next step, I copied the right triangle ADE, this right triangle ADE, in the new page here, and we continue to analyze this right triangle ADE. In this right triangle ADE, it is very easy to see that sinus theta equals to dA over dE. Again, sinus theta equals to dA over dE. dA is y, dE is 12, so in total sinus theta equals to y over 12. This is according to equation 2, while according to equation 1, we have already found out that gm equals to x times sinus theta. So now we can substitute sinus theta in this equation 1 by y over 12 from equation 2. We did it and found out that gm, according to equation 1, gm equals to x times sinus theta, and sinus theta is y over 12. So in total, gm equals to xy over 12. gm equals to xy over 12. So actually, this is side gm, this is equals to xy over 12. In the next step, we join points A and G together by side line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and then at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equal to R. By joining points A and G, we get the right triangle AGN. So copy this right triangle AGN in a new page, and we implemented on this right triangle AGN the Pythagoras theorem. We just right now found out that the hypotenuse AG equals to R. It is the radius of the quarter circle also. We have already found out that AN equals to XR over 12, and finally side GN in total of the right triangle GN, side GN equals to GM plus MN. That is to say, GN in total equals to GM, that is XY over 12, plus GN plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. Okay, again, this is the right triangle AGN. We take off it from the original domain, we just write down, found out that side GN equals to XY over 12 plus Y. The opposite GA equals to R, and AN equals to XR over 12. According to the Pythagoras theorem, in this right triangle AGN, AG square equals to GN square plus AN square. Again, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square. XR over 12 square equals to X squared times R squared over 12 squared, that is 124. So in total, X over 12 squared equals to X squared times R squared over 124 plus GN squared. GN is XY over 12 plus Y, therefore GN squared is XY over 12 plus Y squared. So actually, according to equation 1, we found out that R squared equals to X squared times R squared over 124. Here we took Y second factor from this equation and found out that so y second out to second factor. So what is left from xy over 12 we took from it y second factor. What is left is actually x over 12, and what is left from y after we took from it y second factor? What is left is actually 1 all squared. So here we have this expression y times x over 12 plus 1 squared. And according to the algebraic identity that a times b to the power of m equals to a to the power of m times b to the power of m, this expression y times x over 12 plus 1 square will be equal to y square plus x over 12 plus 1 square. Again, this is y square times x over 12 plus 1 square. And here we have x square times r square over 124, it's equal to r square according to this equation 1. So, according to equation 1, r square equals to x squared times r square over 124. And here we have here this expression x over 12 plus 1 squared. So here we multiplied 1 by 12 and then we divided by 12 in order to have a common factor with x over 12. And we found out actually that in total the numerator of this expression we will have x plus 12 divided by 12 squared, because we multiplied 1 by 12. So in total, according to equation 1, we actually found out that r squared equals to x squared times r squared over 124 plus y squared times x plus 12 over 12 squared. So this expression, so I copied this equation 1 in the new page here. This is equation 1. According to equation 1, r squared equals to x squared times r squared over 144 plus y squared plus x plus 12 over 12 squared. So this green expression, x plus 12 over 12 squared, according to the algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m. So this expression will be equal to x plus 12 square over 12 square. Again, this expression, according to this algebraic identity, will be equal to x plus 12 square over 12 square, that is 144. And then I copied here, this is r square. I copied here, this expression here, x squared times r squared over 124. So according to equation 1, we actually found out that r squared equals to x squared times r squared over 124 plus y squared. times x plus 12 square over 144. This is equation 1. In the next step, we join points A and C together by a straight line. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and then says point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R. In the next step, I copy this right triangle ABC in a new page, and we implemented the Pythagoras theorem on this right triangle ABC. This is right triangle ABC that I got from the original drawing. We just right now found out that the hypotenuse AC equals to R, AB equals to BC. They are both the sides of the square, and all the sides of any square are equal to each other according to our definition. One side of square ABCD equals to y. So in this right triangle ABC, according here by PT is a equation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ABC, AC square equals to AB square plus BC square. Again, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equals to AB square. AB is Y, therefore AB square is Y square, plus BC square. BC is also Y, therefore BC square is Y square. So according to equation 2, we actually found out that R square equals to Y square plus Y square. Y square plus Y square is 2Y square. So according to equation 2, we actually found out that R square equals to 2Y square. Repeat again. According to equation 2, we actually found out that R square equals to 2Y square. While according to equation 1, we have already found out that R square equals to R square times X square over 144 plus Y square times X plus 12 over 144. So here we divided, here we have R square in equation 2 and we have R square in equation 1. And therefore we can substitute R square in this equation 1 by 2Y square from this equation 2. We did it and found out actually that according to equation 1, R square is 2Y square, and it is equal to R square is 2Y square times X square over 144 plus Y square times X plus 12 square over 144. So here we divided this equation 1 by Y square. So 2Y square over Y square is 2. Here Y square will get cancelled, and we left only with 2x square over 144. Here Y square also will get cancelled, and we left only with x plus 12 square over 144. So actually, in total, we actually found out that according to equation 1, 2 equals to 2x square over 144 plus x plus 12 square over 144. Here we multiplied this equation 1 by 144, and finally found out actually that according to equation 1, 2 times 144 is 288. Here 144 will get cancelled, and we left only with 2x square. Here 144 will also get cancelled, and we left only with x plus 12 square. So actually according to equation 1, we found out that 288 equals to 2x square plus x plus 12 square. Here we open the brackets of this expression, and finally found out that according to equation 1, 288 equals to 2x square, and x plus 12 square equals to x square plus 12 square, that is 144, plus 2 times x times 12 is 24x. So here we have 288 equals to 2x square plus x square is 3x square plus 24x plus 144. So according to equation 1, we have found out that 288 equals to 3x squared plus 24x plus 144. Here we subtracted 288 from this equation 1. We finally found out that 288 minus 288 is 0, and it equals to 3x squared plus 24x, and 144 minus 288 equals to minus 144. Here we divided this equation 1 by 3, and finally found out that 0 over 3 is 0, 3x squared over 3 is x squared, 24x over 3 is 8x, and minus 144 over 3 is minus 48. So we actually found out that according to equation 1, x squared plus 8x minus 48 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. We found out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So we put the values of a, b, and c for our specific quadratic equation in this general formula for x, and found out the value of the values of x for our specific quadratic equation. We did it here, and we found out actually that x equals to minus b. B is 8, therefore minus b is minus 8, plus minus square root of b squared. B is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a is 1, so minus 4 times 1 is minus 4, times c is minus 48, and minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So actually found out that x equals to minus 8 plus minus, and inside the root we have 64 plus 192 is 256 divided by 2. So x equals to 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So actually found out that according to the first solution for x equals to minus 12. But because of the fact that x is the length of this line 7GD, x is a length, it must be a positive number, it can never be equal to minus 12, that is a negative number. So we cancel this negative solution for x, and we took into account only the positive solution for x. And the positive solution for x is as follows: x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So actually found out that the length of this line 7GD that is equal to x is equal to 4 units. Okay, so GD is equal to x is equal to 4 units. Okay, thank you very much.